Alright, I'm going to do a quick run through of the Project 1 and getting started with Gem 5 for CSE 420 because my internet isn't working and there's not much else I can do while offline this morning. Anyways, so let's just get started with it. First things you want to do is go ahead and download the PDFs and zip files from Canvas. So that includes the Getting Started with Gem 5, the Project 1, both those are PDFs, download gem5.zip, benchmarks.zip, and test.zip. This guy we technically download during the getting started process, but I believe there is an updated version of this tool right here posted on a Piazza answer, so go ahead and check out the Piazza and make sure you grab the most recent one of these. Anyways, let's get started. So I already have these downloaded, but we're just going to take our gem5.zip, put it wherever we want. I have a folder for Project 1 I'm putting inside of, and then we will just do a quick extraction of it. Takes like 2 seconds. Don't need that anymore. And here's my newly extracted Gem 5. I am personally going to rename this to Gem5-tutorial. You can name it to whatever you want or just leave it as is. It doesn't matter. That's the first step. Pretty easy. Second thing you're going to want to do is go ahead and download all of these tools. So just sudo apt install, and I already did this, so mine will pop up, but you go on do that. Mine personally is not going to work right now because my internet's not working, but yours will work. And so I'll ask you if you want to install those. You'll click yes. It will take a couple seconds to maybe 2 or 3 minutes depending on how fast your internet is, how fast your PC or VM is, and if you had it installed already. And then there's one more thing we're going to install that is unfortunately not listed here. It is on the Piazza page if you just want to go check there. A couple people asked questions about it, and he posted some post and answer for it, but I'm just going to pull it out of my group's Discord. So what we also need to install is this library. Libboost. There. So libboost -all-dev. Make sure you install that one as well. That will take care of one issues that most people are having in the beginning of building Gem 5. Again, that's not listed here for whatever reason, but you do need it. Alright, so this is all, if you extract it to like a different place or whatever. Yeah, anyways, skip all that if you know what you're doing or follow these instructions. The important thing is that you are looking at the home folder for Gem 5. So Gem 5 is the parent, and then inside it you have all these things after you extracted it. So nope, not that one. You're going to want to either open this up in a terminal, or if you have a terminal open, just cd into it. But once we are there, and I'll show you my path, I'm inside my Gem 5, and here I can see all of these folders. So this next part is really easy. It is one command. We are going to do this command right here. Make sure that you are doing -J4, -J8, or if you know how many threads your system has, then do that. If you don't, just do -J4 and it should be fine, or -J8 and it should probably be fine too. So my PC has 16 threads, so I'm going to do -J16, and what that means is that it will build it in a multi-threaded way instead of doing it all in serial on a single thread. It's much faster to do this in parallel. So scones, yep, I already have that done, and you can just go ahead and ignore that warning message right there. It doesn't really matter. And then it will start. And every time I've done this, if it fails, it does so after about the first 30 seconds or so. But if it doesn't fail, which it looks like it's not, it'll start going past this. And then depending on how fast your PC or VM is, this could take 7 or so minutes, which is about what it takes for me. Or I've heard this thing can take like 40 minutes if it's on a slower system. Alright, so it's been about 5 or so minutes, and mine is finished building. When it's done, it will spit out this last line, alpha/gem5.opt, and then it'll say done building targets, and then it'll put you back to your command line. So we are ready for the next part. And this is when we're going to go ahead and go back to all those wonderful things we downloaded earlier. So we're going to take the test.zip, which we downloaded from Canvas, go into our gem5 folder, the directory that contains all of these, so build ops, configs, ext, etc., etc. We will paste that here and then extract it. Don't need to zip anymore. And so you'll have 2 folders, test and tests. Just ignore the test and leave it there. We are just going to use tests. Everything's already configured to use the test folder, so that should be good. And then from that directory again, we are going to use the command line and type this next following command. This is simply just to make sure that your alpha gem5 processor is working and simulating properly. So I should already have mine done, but I'll go and type it for you. build/alpha/gem5.opt ./config/example/scpi-c test, so on and so on. It's just copy and paste this, or just write it out line by line into your command line, and then it should work. Mine just ran. My computer's pretty fast. Yours might run a little bit slower, but it will spit out all of this right here. Ignore this. This shouldn't actually cause any issues. If it does, then I don't know how to help you. But that's all fine. And then it'll start real simulation. It'll do all this. This is the output of our hello world. Pretty easy. And then it will exit code 13. That's all fine as well. Perfect. It's working. Awesome. Next step is to download the cross compiler. There are 2 ways to get it. You can download it from this web address using command line. So just wget. You just go like this. Again, my internet is currently not working, so I can't do that. Luckily, I already have it. So download it from there, or there's an updated version on the class Piazza page. I would recommend downloading that one just because a lot of people had issue with the one from this web address. I haven't had any issues, but you might. So we are going to go back into our folder here. And you can just drop all your downloads into this folder if you wanted, or I just keep mine separate. So you should just download your cross compiler into this folder. And then from this folder, we are going to want to make sure that gets opened in the command line, which we're already there. And we're going to want to do this command exactly. Do not uncompress this from your graphical file system. You have to tar this from the command line, or else it won't work properly. So tar xjf. Don't remember what those do, but they're important. And then go ahead and do that. It will take a couple seconds, and then boom, it's done. And if you look at your directory, you might be like, not much is different. Well, you have this opt folder here, Inside that is cross tool, that, and then all of these kinds of things. So that's the good stuff for after. Anyways, that installs correctly and you don't need to worry about it anymore. I just get rid of that zip because I don't need it. And then for the next part, yeah, just make sure that you get the here. I'll go ahead and CD down to it. But so I'm currently in my gem5 tutorial, and then I have all these folders. So CD opt cross tool, so on, CD bin, all these things. That's fine. So /pwd, not /pw, just pwd. So basically, you just need to remember this string here. That is your path to the cross tool. Just make sure you write that down or just remember it, because we will be needing that in a little bit for the next step. Anyways, I'm just going to reopen this folder in terminal. Oh, yep, next we're going to need to make a hello.c. I already have one made, so I'm just going to copy mine real quick. Paste. It's a really simple hello world program. Yeah, it's the most basic hello world for C. Anyways, so we are going to now work on that. So, you know that string I had you copy earlier? That is going to be for this part right here. That is in place of the alpha tool bin. So, for me, that's going to be op/cross tool. And yours should be the same, unless if you moved it for some reason. But assuming that you're still in this folder here, this directory, and you see the opt subfolder, it's going to be opt/cross tool /gcc-3.4, so on, then /alpha-unknown, then /bin, then /alpha-unknown-linux-gnu-gcc. It's great. And then we're going to do -static space -o. That's our object file that we're creating right here. And then hello.c, which is the hello world we just created. You could have named this anything you wanted or made any program you wanted. We're just doing it just to test. Do that, and then what you'll see is that we created a new hello world binary right here. Perfect. So next we will run /simulate that binary. So step 3 here, we're gonna do this: build alpha gem5.opt /config/example /se.py-c hello world. Again, just pretty much put that in there line for line, -c, and then we're going to do hello world. Yay, and this time it ran the simulation from the program that I wrote and compiled myself. So hello world right there, perfect. It is successful. If yours doesn't look exactly like his output, that should be fine. Like, I don't know why that's coming up, because I don't think mine does that, but whatever. Oh, sure. Yeah, you can also do this. That just shows you the stats. Okay. Fuck. There we go. Okay. But yeah, the M5 out here has your stats.txt. Anyways, so part 6, or step 6 in part whatever. We're just going to do this with cache flags. So build hello world, except instead of doing it just like that, we're actually going to do dash dash caches. L2 we didn't actually change any cache flags, but it works. Just we'll be doing this part in the next document. So now you're going to want to go ahead and open up the project1.pdf. And before we can get started with any of this, we are going to need to do something. So first thing you're going to want to do is go ahead and grab the benchmarks.zip that you downloaded from Canvas and paste that into your your just gem5 directory. Make sure you go ahead and unzip it. Don't need the zip file anymore. And then here is our uncompressed folder. We are going to rename that to just benchmarks, just to make our life a little bit easier. Inside this folder, you have another folder. Oh, I screwed up slightly. Here. Go ahead, just unzip it, and then so it unzips to benchmarks-1. Inside that is another folder. This is the one we need. Go ahead and just move that up a directory. Oh, I moved it up one too many. Anyways, take the benchmarks and just move it to the same directory as benchmarks-1. That leaves you with an empty benchmarks-1 folder. Delete that, don't need it. Delete that zip, don't need it. Here we go. So benchmarks, and then inside it will be 4 folders plus a text file, Decastra. All of these are the ones we'll be using for this project 1. And the first thing we're going to want to do is delete these. Actually, let me do an example run to show you what happens, because they're currently not compiled correctly. So yeah, let me see. I know. Okay, so here, basically, what we're going to be doing is running pretty much this script right here, and this is again just in the PDF. So it's going to be running this, but we're going to be doing it with all these configurations he lists. So this is one that's listed here. I can go ahead and run it right now, and this should fail, and I'll explain why it fails in just a second. Perfect. Fatal. Object file architecture does not match compiled ISA alpha. So we are doing this project for the alpha processor. We compiled our gem5 for alpha. Unfortunately, and this took me a little while to figure out, these guys right here, these binaries he has, are compiled for the ARM processor. Don't know why, but we're going to go ahead and actually just delete them. So Decastra small and Decastra large binaries are now gone. We're left with the raw.c files, and then we need to recompile these for alpha. Now earlier we wrote a hello world.c and then compiled that for the alpha processor. So that's going to be the exact same as this. And to make life a little bit easier, I'm just going to paste these into my home directory with the original hello world.c. And then I will recompile them exactly as I compiled the earlier example, just switching out the file names. So let's see, what was it? Alpha tool bin, right, okay. So it's gonna be opt cross tool, and then we're gonna do did gestra underscore small. So it's going to be the exact same name as this, just without the .c, because that's the file we deleted. It's going to take a second, and then we don't need the large, but I'll go ahead and compile to large. Right, so those should be compiled correctly, and then I will go ahead and take this binary and that binary, and then cut and paste them into here. So now these should work. So real quickly, if we go ahead and run this command again, this would be the part one, this would be this configuration right here. Boom, no fatal event, and then it's going to start simulating. So that's pretty much it. The other thing you're going to want to do is you can either write all these by hand and run them one at a time, or you can just make a shell script. I recommend doing a shell script. It's pretty easy. I believe at the beginning of this document. Here we go. To make a shell script, and I'll just show you mine like really quick. It is literally, I don't care. It is this first line right here, which is very important, and then these 8 commands, and that's it. So I'll show you once this is done running. Yeah. So this, let me see if I can explain that real quick. Okay, so this is our simulator here. This is how we save our data. This is the location to save it to. So what I do is I just have a directory that's gonna split. All my save is done like this. So my saves start with the project 1 submission, and then I split the first 4 into a subdirectory called problem 1, the second 4 into a subdirectory called problem 2. Then inside of both of those subdirectories are a subdirectory for each run. So 1, 2, 3, 4 for the first, and 1, 2, 3, 4 for the second. You don't have to do yours like that. You can save it however you want. That's just how I do it. But anyways, so this right here, that is the processor. This line here is for saving. This is using, again, just some of the simulation stuff. This specifies our CPU type. We're using time simple CPU, and then this, all of this through here is messing with the caches. Make sure that you, and he has it listed down here, what you need to do. Make sure that you use all of these values properly. And then after that, it's just a basic compile step. So -c. And then this is the Decastra small binary we created a few minutes earlier, object file, and then here's just our input data. It's pretty simple. Yeah, and then yours will do a bunch of those. You make a shell script. So .sh, making a quick shell script. So to do that, you're gonna want to go ahead and type vim nano, or you can use a graphical editor. Run.sh is what you want to name it, and then you're going to want to first type pound exclamation point /bin /sh, and then below that, you would then add all your runs, each on its own line. And then if we look at this, you'll see our run.sh here, but we can't execute it. So you're quickly going to want to chmod +x run.sh. And then now you can execute it. Mine shouldn't do anything because I don't have any commands in it, but yep, that's how that will work. And that's pretty much it for this project. Good luck.